Rutherford's nuclear model of atom, alpha particle scattering experiment. The experiment involved the bombardment of a thin sheet of gold by alpha particles. These particles were obtained in the form of a narrow beam by passing through a slit in a lead plate. A circular screen coated with zinc sulfide ZnS was placed around the foil to detect the deflection suffered by alpha particles. Whenever an alpha particle struck the screen, a tiny flash of light was produced at that point. Observations. Number 1. Most of the alpha particles, nearly 99%, passed through a gold foil undeflected. Number 2. Some of the alpha particles were deflected by small angles. Number 3. A few particles were either deflected by very large angles or were actually reflected back along their path. Explanation of Rutherford's nuclear model of atom. He explained his observations as follows. Number 1. Since most of the alpha particles pass through the foil undeflected, it indicates that the most of the space in an atom is empty. Number 2. Alpha particles, being positively charged and having considerable mass, could be deflected only by some heavy positively charged center. The small angle of deflection of alpha particles indicated the presence of a heavy positive center in the atom. Rutherford named this positive center as nucleus. Number 3. Alpha particles which make head-on collision with heavy positive center are deflected through large angles. Since the number of such alpha particles is very small, the space occupied by the heavy positive center must be very small. Main points of Rutherford's nuclear model of atom. Main points of this model are: Number 1. Most of the mass and all the positive charge of an atom are concentrated in a very small region called nucleus. Number 2. The nucleus is surrounded by electrons which are revolving around it at very high speeds. The electrostatic force of attraction between electrons and the nucleus is balanced by the centrifugal force acting on the revolving electrons. Number 3. Total negative charge on the electrons is equal to the total positive charge on the nucleus, so that atom on the whole is electrically neutral. Number 4. Most of the space inside an